I will explain the gains from trade, the concepts of absolute advantage and comparative advantage using this example. We will make assumptions to make things simple, and in this simple world we have two countries. We have the United States and Japan, and there are only two goods produced in these countries: computers and wheat. We also assume that these countries use only one resource, and that is labor. With these assumptions, our question is, how much of both goods each country will produce and consume, if the country chooses to be self-sufficient, and if it trades with the other country. Let's assume the United States has 50,000 labor hours. And in the United States, one computer can be produced using 100 labor hours. That means using all 50,000 labor hours, the United States can produce 500 computers. Also, in the United States, 1 ton of wheat can be produced using 10 labor hours, and using all 50,000 labor hours, the United States can produce 5,000 tons of wheat. We can put that information on our production possibilities curve for the United States. If the US allocates all its labor input in the production of wheat, the United States will produce 5,000 tons of wheat, but no computers. If the US allocates all 50,000 labor hours in the production of computers, the United States can produce 500 computers. Or, of course, we can allocate the resources in the production of both goods. So the production possibilities will be any point between these two combinations. For simplicity, we're just assuming that it is just a straight line, so we're not making bowed out to make the case simple. So I'm just going to put this straight line between these 2 points. So using all 50,000 labor hours, the United States can produce any combinations of these two goods which are on the production possibilities curve. So this is the country's production possibilities. Suppose the United States chooses to be self-sufficient. That means this country does not trade with other countries, produces only for domestic consumption. So what do we have here? Then we need to allocate the resources equally in the wheat production and in the computers production, so that we have both wheat and computer for domestic consumers. Let's do that. We're using half of the total labor hours, which is 25,000 labor hours. That's half of the total 50,000 labor hours. If we use half of that to produce computers, the United States can produce 250 computers. So I'm going to put that here. So we have 250 computers produced with half of the resources, and the other half of the resources will be used to produce wheat. And when we do that, the United States can produce 2,500 tons of wheat. So that's going to be right here. That's 2,500 tons of wheat. That means the United States, among all the production possibilities, chooses this combination. So let's make it point A. Okay, so that's point A, where the country chooses to produce 250 computers and 2,500 tons of wheat. So we just derived the production possibilities curve in the United States without trade. And that point A represents both production in this country, and also consumption, because remember, we are self-sufficient. I'm going to put consumption here. We're self-sufficient. We consume what we produce. So point A is both production and consumption level in the United States without trade. Now let's do the same thing for Japan and assume that Japan has 30,000 labor hours. And one computer can be produced using 125 labor hours. That means using all 30,000 labor hours in this country, we can produce 240 computers. And in Japan, 1 ton of wheat can be produced using 25 labor hours. If we use all the labor hours to produce wheat, in Japan, we can produce 1,200 tons of wheat. And of course, we can put that information on Japan's production possibilities curve. So if we use all the resources to produce wheat, we can produce no computers but 1,200 tons of wheat. That's this point here. If we use all the resources to produce computers, we can produce 240 computers but no wheat. And of course, we can allocate the labor hours in the production of both goods, and Japan can produce any combination in between these two combinations. So I'm going to put that here to drive the production possibilities curve for Japan without trade. If we want to be self-sufficient in Japan, we need both goods. We need to produce both goods in Japan. So let's take a look at when Japan is self-sufficient. And let's assume Japan uses half of its resources to produce computers and the other half of its resources to produce wheat. So half of the 30,000 labor hours is 15,000 labor hours, and Japan can produce 120 computers here. Let's put that here, 120 computers. And using the other half labor hours, Japan can produce 600 tons of wheat. Let's put that here somewhere. That's 600 tons of wheat. So this is the production combination Japan chooses to be self-sufficient. Let's make it let's say point B for Japan. And once again, since there is no trade, Japan produces for its consumption. That point B represents both production in this country and also consumption in this country. Now let's assume the United States trades with Japan. And we have the initial production possibilities. That doesn't change. But what changes is the production of wheat and computers the U.S. produces after trade. Now let's say the United States chooses to produce 3,400 tons of wheat. When that's the case, we need to find out with the remaining resources how much the United States can produce, how many computers the United States can produce. The labor hours needed to produce wheat is 34,000 hours because each ton of wheat can be produced using 10 labor hours. So if we use 34,000 labor hours to produce wheat, we have 16,000 hours remaining to produce computers, and using 16,000 hours, in the United States, people can produce 160 computers. Let's put that here, 160. And here's the production possibility for the United States after specialization and after making that decision to trade with Japan. So the United States specializes in the production of wheat. More resources are allocated to produce wheat, and the United States produces more wheat and fewer computers. Now let's allow Japan to trade with the United States, and Japan, in this case, specializes in the production of computers. That means Japan will allocate more of the labor hours to produce computers. And in that case, let's see what would be the new production choice. In our example, let's now assume Japan produces 240 computers. And remember, if this country produces 240 computers, there's no resources left to produce any wheat. So the wheat production will be 0. So Japan will choose this production possibility here at this point, where the country produces 240 computers but no wheat. Now these two countries trade, and suppose the United States exports 700 tons of wheat to Japan. That's Japan's import of wheat from the United States. And also, let's suppose the United States imports 110 computers from Japan, and that's Japan's exports of computers. Let's put all of that together. The United States produces 34 tons of wheat and exports 700 tons of wheat to Japan. Now we have in the United States 2,700 tons of wheat for domestic consumption. And also the United States will import 110 computers from Japan, and in the domestic market we have 270 computers available for consumers. Although the United States produces the A combination, so let's put that here. So we have the A combination of goods produced in the United States. We have the, let's say, A prime combination of goods consumed in the United States. So if we look at what happened before and after the trade, for this country, it is only possible to consume what the country produced, which is on the production possibilities curve before trade. But after trade, people in the United States can consume a combination of wheat and computers that exceed the production possibilities. This is outside the production possibilities. What happened in Japan? Japan imports 700 tons of wheat from the United States, so that is coming from the US. That's 700 tons of wheat. Now the Japanese people can consume 700 tons of wheat, but since Japan exported 110 computers to the United States, Japan now has 130, so that's going to be 130 computers. So when we look at the consumption possibilities for Japan, if we combine the two, once again, we have this combination that is outside Japan's production possibilities. Initially, Japan produced this A combination of goods produced and consumed before trade, but after trade, Japan also produced this A combination, but now what happened to the consumption possibilities? The consumption possibilities increased. Now we have this A prime combination. This is how much the Japanese people can consume. Then that's all because of trade. So, what kind of results can we derive from this example? 1. Before trade, production possibilities and consumption possibilities are the same. Second, after trade, consumption possibilities exceed production possibilities. Third, total world production increased. In the world, total wheat production increases from 3,000 total wheat to tons of wheat to 3,400 tons of wheat. So the net gain is 400 tons of wheat. And the total computer production increases from 370 computers to 400 computers. So the net gain is 30 computers. On the consumption side, the US consumers can now consume 200 additional computers and 200 tons of additional wheat. And in Japan, consumers can now consume 10 additional computers and 100 tons of wheat, additional wheat the Japanese consumers can consume. So in this two-country, two-good model example, we just saw that trade makes everyone better off. We need to add one more thing to our analysis. Now we need to ask what determines specialization and trade. We need to first understand two important concepts: absolute advantage and comparative advantage. Absolute advantage is the ability to produce using fewer resources. If you look at these two countries, we need to ask this question: which country has absolute advantage in the production of computers? For the United States, it takes 100 hours to produce one computer. In Japan, it takes 125 hours to produce one computer. Since for the United States, it takes fewer hours to produce one computer, we can say that the United States has absolute advantage in the production of computers. Now let's take a look at who has absolute advantage in the production of wheat. For the United States, it takes 10 hours to produce 1 ton of wheat. In Japan, it takes 25 hours. Once again, the United States uses fewer labor hours, fewer resources to produce wheat. So the United States has also absolute advantage in the production of wheat. Now we need to look at comparative advantage. What is comparative advantage? It is the ability to produce at a lower opportunity cost. So, in the United States, what is the opportunity cost of producing computers? In the United States, for 500 computers, 5,000 tons of wheat can be produced. So that means the cost of producing one computer is 10 tons of wheat. In other words, the opportunity cost of producing one computer is 10 tons of wheat. In Japan, For 240 computers, they can produce 1,200 tons of wheat. In other words, for one computer, 5 tons of wheat can be produced. What is the cost of computers in terms of wheat in Japan? It's one computer for 5 tons of wheat. In other words, the opportunity cost of producing one computer is 5 tons of wheat. So, who should be specialized in which product? Of course, the comparative advantage concept tells us that we need to choose the one product that has the lower opportunity cost to produce. If you look at the opportunity cost in both countries, in the United States, one computer costs 10 wheat, and one computer costs 5 wheat in Japan. Which one is cheaper? It looks like producing computers cost cheaper in terms of wheat in Japan. So let's put that here. Opportunity cost of wheat is opportunity cost of producing computers less in Japan. So Japan should specialize in the production of computers and produce more computers and export computers to other countries. And if we look at the opportunity cost of wheat, in the United States, 1 ton of wheat costs 1/10 of computers. In Japan, 1 ton of wheat costs 1/5 of computers. Which one is less? Of course, in the United States, one wheat can be produced cheaply. When we take the price in terms of computers, and we say that the opportunity cost of wheat in the United States is less in the United States. So countries choose to produce the good that has a lower opportunity cost. And our result in this example is that what determines specialization and trade is comparative advantage. It is not absolute advantage. As we see in this example, the United States has absolute advantage in the production of both goods, but still there is trade between the two countries, and both countries still benefit from that trade because there is a comparative advantage in each country.